Welcome to Parent Functions video. The best way to use this video is to take notes while I'm teaching and complete the problems on your own. Pause the video whenever you need to, and pause it again when you get to a you try, attempt the problem on your own, and then press play when you're ready to see the solution. These are the items we'll be covering in this section. These are the 6 parent functions we're going to cover. There are lots of other parent functions, but these are the 6 we're going to focus on in this video. For each parent function, we're going to write the family and the equation, create a table of x and y values, to graph the basic shape, we'll identify the domain and range, and we'll note any important characteristics. We'll begin with the quadratic function. So the name of this family is quadratic. The equation is f of x equals x squared. And we'll do the domain, range, and notes once we graph it. So we're going to plug this in. We're going to use this xy table that I already built. You can use any values of x you want, but this will give us a good idea of what's happening around the origin. So we'll plug in for y. Make sure you use parentheses, otherwise you will get the wrong answer. You should get 4. That's the ordered pair, -2, 4. We're going to plug in each of these into the function, and then we'll graph them. Feel free to pause the video and move at your own pace. You don't need to show your work, but sometimes it's helpful, especially in the beginning. So we're going to plot these ordered pairs, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then we're going to connect this into a U shape. Make sure you don't make a V shape here. Great. Now let's look at the domain. Domain is our x values. So we're looking along the x-axis. So we want to look as x gets really, really small. So as x gets really, really small, this graph is existing all the way forever. It's going to keep going. And so the domain of this function is all real numbers, or x is in the real numbers, or from -infinity to infinity. When we look at the range of the graph, we're looking at the y-axis. So we're looking at where the y values exist. And right away you notice that there's no graph over here. So that means the y values don't start until that point there when y is 0. So the range is y has to be greater than or equal to 0. Some notes, we've got a U-shaped graph here. Now this has a vertex of 0, 0. And this is symmetric about that y-axis. So let's take a look. If I were to fold this U in half over that y-axis, it would fold perfectly. So it's symmetric about the y-axis. We're going to continue the same process for 5 more functions. So a linear function, the family is linear. The equation is f of x equals x, and we'll go ahead and graph this. These are a little bit easier. The y is the same as the x, so we've got -2, -2, -1, and this should look familiar, especially if you watched my graphing linear functions. We're going to use our ruler again here. And this is the linear function. So the domain, we'll take a look at our x values. And it does exist everywhere on both sides of the graph here. So you can say all real numbers. And let's take a look at the range, our y values. And it does exist everywhere. So maybe you say all real numbers, or you use the interval notation or set notation. And then any notes here. So this is not symmetric about the y-axis. Notice that it doesn't have a V over there, or it's not symmetric over there, it's not symmetric over the x-axis, but it's symmetric about the origin. If I were to kind of fold it over this way diagonally, it would match. So this is symmetric about the origin. Good. On to absolute value. The family name is absolute value. The equation is f of x equals the absolute value of x. So let's talk about absolute value of x for a moment. Absolute value means the distance from 0. So it means that distance is always positive, so it's going to always be a positive answer. So when we take the absolute value of -2, we get 2. Absolute value of -1, we get 1. 0 is 0 away from 0. 1 is 1 away. 2 is 2 away. So we'll graph those points. And now we're going to draw a V shape here. The absolute value is a V shape. So if you want to write that right away in your notes, you can do so. And then let's talk about the domain. So we'll look along the x-axis here, no problem. So we've got all real numbers. And the range, our y-axis, you can see right away there's nothing over here for the y's. It starts at 0, so y is greater than or equal to 0. Some other notes is it's symmetric about the y-axis again. And know that there are lots of notes that we could give for all of these. You could say that it's got a vertex at 0, 0. And then we'll move on to the next one. All right, we've got the exponential function. Now this one is a little bit tricky. So the family is exponential. And the equation is f of x equals c to the x power, where c is a constant number. So I'm using 2 as an example here, but it could be 3, 4, 5, etc. So when we plug this in, we have to be really careful. That's not going to give us a negative value. It's actually going to give us a fraction, 1 over 4, or 0.25 might be a little easier to graph. We get -1, we get 1/2, or 0.5. 2 to the 0 is not 0, that's 1. Thinking back to our exponent properties, we've got 2 to the first power is 2. 2 to the second power is 4. Graph this really carefully. We've got -2. 0.25, -1, 0.5. And the way this graph looks is it kind of comes down, it gets really close, but it doesn't actually touch that x-axis. So let's talk about that domain. So when we go in this direction on the x-axis, this graph is going up forever, which means it's going to eventually go out. So, and in this direction, it's going everywhere. So we've got all real numbers again. Let's look at the range. We've got nothing down here, but is there a value at 0? And the answer is no, there's an asymptote here. It's never actually going to hit that x-axis, so it's going to be just greater than 0, but never actually 0. It's going to get close and close and close, but never actually touch. So what are some notes we can write? I'm not really sure what kind of a shape, maybe a J shape. Maybe that's what you want to say. You could say that it's got an asymptote. And then we'll move on to rational functions. So for rational functions, the family name is rational function. Its equation is f of x equals 1 over x. All right, now these are going to get pretty interesting. So we'll plug it in. We get y equals 1 over -2. So that's -0.5. Y equals 1 over -1. We get -1. Y equals 1 over 0. When you type that into your calculator, you do not get 0. A common mistake is to write 0. You get error. That means it does not exist here. And then we keep going. Y is equal to 1 over 1. Y is equal to 1 over 2. All right, we'll deal with that error in a minute. Let's graph what we can. So we've got -2, -0.5. We've got -1, -1. We skip that 0. We don't know what to do with it. We've got 1, 1. And 2.5. The way this graph looks is it's 2 pieces, and it goes like this. So you could write that right away. It's got 2 pieces in our notes. Let's look at our x-axis for our domain. So it's fine over here, but we got a hole at 0. So we can say that x just cannot be 0. You can think right here when x was 0, we got an error. Let's look at our range, our y values. Over here we're fine, over here we're fine, but again, we're having that asymptote like we had over in the exponential function, so y cannot be 0. So the rational function looks a little bit different. We've got one last parent function to graph. That's the square root function. I'm just going to draw a little thing over that. So our family is square root. Our equation is f of x equals the square root of x. And we're going to go ahead and plug these in. I guess I'll stay with the green. When we plug in square root of -2, you get that error message again. So no. When you plug in -1, square root of -1, it doesn't work either. When you plug in 0, though, you should get 0. When you plug in 1, you get 1. When you plug in 2, you get about 1.14. So let's see if we can graph this. We know we have a dot at 0, 0 and 1, 1, and then at 2, a little bit more here. And this graph is going to look something like that. All right, let's look at our domain, our x values. Well, we're fine in this direction, but we've got nothing over here. So x has to be greater than or equal to 0. Let's look at our range. We're fine up here, but we've got nothing down there. So we have y has to be greater than or equal to 0. All right, what kind of notes? Maybe you want to say it's one piece. Not really sure what kind of a shape this looks like. Maybe your note is that it kind of looks exponential, but not quite. All right, now, how do we graph using Desmos? We just graphed a whole bunch by hand, and that's not fun, so I'm going to talk about Desmos. To graph with Desmos, you're going to type into your browser, desmos.com, and you'll get to this screen here. You're going to hit Start Graphing, and then you'll see this graph right here. So in here, you can type anything you want, and there's our quadratic function. We've got, if you need to find the keyboard function at the bottom, we've got the square root of x. You can unhighlight it by hitting the color, bring it back, or get rid of it completely. So Desmos is a great tool. Now that you know how to use Desmos, you're going to graph each of the following functions in Desmos one at a time. Sketch the result on your graph paper. Be sure to indicate the number and the equation. Press pause here so that you can get all of those equations into your Desmos. And then after you've got all of that written down, you're going to analyze each of these by groups. So you're going to answer the following problems. Just pause here, take a moment. Press play when you're ready to see the answers. So these are all the graphs graphed in Desmos. Pause it to check your answers. And these are all the answers to those questions. This concludes Parent Functions video.